The next type of genetics problem I'm going to show you guys how to do is a dihybrid cross. With the dihybrid cross, you are trying to see the probability of inheriting two traits simultaneously. So trait 1 is coat texture. Trait 2 is coat color. So we're trying to see what is the probability of offspring inheriting certain combinations of coat texture and coat color. So rough coat is dominant, smooth coat is recessive. Brown fur is dominant, white fur is recessive. So let's say we have two parents, both of whom are heterozygous for each trait. So we will use, for coat texture, we'll use T's. So the parents are big T, little t, because we said they're heterozygous for coat texture. And for coat color, they're going to be heterozygous as well. And let's use B, because C's look the same when they're uppercase and lowercase. So we'll use B's. Big B, little b. And I said both parents are the same. So those are going to be our parents. In order to figure out allele combinations, it's not as simple as just taking a T or taking a B. We need to figure out how many, or what are the possible combinations that this parent can give in terms of how many alleles, what allele of coat texture will pair with what allele of coat color. So in order to do that, we're going to FOIL. So by FOIL, I mean first, outer, inner, last. So first T and first B will be this. Outer T, outer B is going to be this. Inner T, inner B is going to be that. Last T, last B is going to be this. FOIL. First, outer, inner, last. First, outer, inner, last. And it's going to be the same for both parents. So the next thing we're going to do is to fill in our Punnett square. And for these crosses, we're going to do a 16 box. And we're going to put the allele combinations from each parent across the top and along the sides. So we have and because the parents have the same genotypes, I'm going to erase this for some space. We're going to put the same ones across the side. They're not always going to be the same, but in the case of parents with a similar genotype, they will be the same. So now we're going to fill in each box. I'm going to keep all the T's together for the simplicity's sake of trying to determine whether or not they are dominant or recessive for the trait together in this trait. So if we keep the T's together, it'll make it easier when we are trying to determine phenotypes. Okay, so now that our square is filled in, the next thing we need to do is determine what are the possible combinations of phenotypes that these parents can produce. So we're going to do the dominant trait, first trait dominant paired with the second trait dominant. That is going to be a rough coat with brown fur. First trait dominant, second trait dominant, rough and brown. The next combination is going to be first trait dominant, second trait recessive. That is going to be rough with white. The next combination is going to be recessive dominant. That will be smooth with brown. The next combination is recessive with recessive, and that will be smooth with white. What we'll be looking for here with this one is at least one big T, so one big T and at least one big B. So it's going to be at least a big T, and this one doesn't matter if it's big or little, and then at least a big B. It doesn't matter if the next one is big or little. So how many of these over here are going to have at least a big T and at least a big B? We've got 1, 2, 3, 4, 5, nope, 6, nope, 7, nope, yes, actually, 8, nope, nope, 9, nope, nope, nope. So we have 9. The next one we're going to look for is how many of them have at least one big T, and then the recessive, white, it's recessive, so little b, little b. So how many of them have a big T and all little b's? Big T, all little b's. 1. Big T, all little b's. 2. Nope, nope, yep, nope, nope. So that's 3. Next, smooth and brown. So we're looking for a recessive, so it's going to be little t, and then dominant. A big B, and the next one doesn't matter. So we'll go brown here. Oh, those colors are all pretty similar. We'll go green. All little t's, at least a big B. 1, 2, 3, nope. So we got 3. And the last one is smooth and white, both are recessive, so it's going to be little t, little b, little b. How many of those do we have? 1. So our phenotypic ratio is going to be 9 to 3 to 3 to 1. When you have parents who are heterozygous for both traits, it's always going to be 9 to 3 to 3 to 1. Usually with a dihybrid cross, you're going to have a ratio something along the lines of 8 to 0, 8 to 0, or 6 to 2, 6 to 2, or 16 to 0 to 0 to 0. It's going to be some combination of even numbers. They're all going to be that, except for this one. When you have parents who are heterozygous for both, mating with each other, that's the only time you're going to get this weird combination of uneven numbers. It's always going to be a combination of even numbers. Okay, so if you get any other combination of weird numbers that's not this, you got to recount.